Hi, this video is about the pH scale and how to do some pH calculations. So you guys watched that previous video, and Mr. Paul Anderson, I think he thinks of P as the pH of the power of hydrogen. But it's a way to measure hydrogen ion concentration or hydronium ion concentration. And the pH scale is logarithmic, base 10. So it's easier to express the concentration as a pH rather than writing the molar concentration, which would be, something very small, times 10 to the always, almost always. So just some, common household items in their pH values. And you can see the negative log of 1 times 10 to the is just going to equal the power. So you don't need to even use a calculator with those. If it's 1 times 10 to the negative 10th, the pH will be 10. You will have to have a log calculator with log base 10 when it's not 1.0 times 10 to the whatever power. So notice also this other image here is showing you that as the hydrogen goes down, the hydroxide goes up. They're inversely related because we know the product of the two concentrations equals kW, which is still 1 times 10 to the negative 14th. So calculating the pH of strong acids and bases, that's all we're going to do in this course. Later you'll look at, in later chemistry courses, doing this for weak acids or weak bases. So we're going to assume that these acids are completely, or bases completely dissociate. So we're not going to try to trick you and throw a weak one in there. So calculating between pH, pOH, I gotta fix my slides, hydronium and hydroxide, it's actually pretty easy. This is a chart that can really help. I highly recommend that you pause the video and put this into your notes. It's just kind of a map that tells you, like, if I want to go between pH, and then there's also pOH, which is a measure of the hydroxide ion concentration, the sum of the two of those equals 14. You can also see, like, the hydronium and the hydroxide, the product of the two is equal to the kW. And then depending on what you have, so if you have the hydroxide ion and you want the pH, you could go and calculate the pOH by taking the negative log of that number. Then you'd have the pOH. You could then subtract that from 14 to get the pH. So, and there's different roads you could travel. You could have also, use kW, get the hydrogen ion first, and then take the negative log of that to get to the pH. So you'll also notice when you do the homework, depending on the route that you take, if it is a possible two-step problem, you might get a little bit different answer than me, which is totally fine. Don't worry. So you do need to have a log base 10 calculator, which I think most of you do. If not, there are ones available online. So I just want to do some examples with you and talk you through this. So for this problem, we want to find the pH, and we know it's an acid, and we're going to have to assume it's a monoprotic acid, that this concentration, so if it's, I wouldn't try to trick you unless I give you the formula or the name. So it's going to, whatever the hydrogen ion concentration is, the same as the concentration of the acid. So pH, I know the hydrogen ion, so I'm just going to take negative log of, I'm starting here, I'm going to pH. So I'm going to take the negative log of the hydrogen ion concentration. So I would just sub in negative log of 2.5, 10 to the negative 3. And when I do this on my calculator, I just put it in not negative, and then I reverse the sign. So pH and pOH are always positive, and they also do not have a unit, whereas if you're solving for hydrogen or hydroxide, those are going to be molarities. So when you plug this in, you should get 2.6. We're not going to worry about sig figs. I think we're just going to kind of consistently go to about the tenths. So later when you take more chemistry, you'll see that there's a really interesting set of sig fig rules for log base 10. But I don't want to trouble you guys with that now. So anyways, let's keep going. So here's another problem. So now I want to find the hydrogen ion concentration, and I know the pH. So now I'm going to go this way. So to find pH, I'm going to take, sorry, my brain isn't working. To find the hydrogen ion, I'm going to take the inverse log base 10, which is 10 to the negative pH. So if you hit inverse log on your calculator, it'll do 10 to the caret usually. So you can do that or just put in 10 to the, so it would be 10 to the negative 2.6. And then another thing is, some people like just leave it in that format, but please don't. I want this always to be a whole number. So put that in your calculator, and then you will get, my calculator gave me this, and you could also change that into scientific notation. Either one is fine. All right, so let's just do a few more. So here's an example where now I'm giving you the acid and the molarity of the acid, and I want the pH. So we want to start at hydrogen ion and go to pH. So we want to take that acid, and again, we're going to always have strong acids and strong bases, so 100% ionization. So this, if this is 0.10 molar, then the hydrogen is also 0.10 molar. So now that I know that for sure, then I can, go and calculate pH by taking the negative log of that number. And this one is one of those easy ones because it's really 1 times 10 to the negative 1, so the pH is equal to the exponent, or 1. Couple more. This one is a base, so barium hydroxide. We're going to calculate pH and pOH. Once you have one, you always have the other because the sum of the two is 14. And then we're starting with 2.0 10 to the negative 4th molar solution. So the first thing you're going to want to do is write the correct formula for barium hydroxide. Then you would want to dissociate it. And then if we know that we made 2.0 10 to the negative 4th molarity, then we're going to have 4.0 10 to the negative 4th moles of the hydroxide ion per liter. We also have 2 times 10 to the negative 4th for the barium, but we're not interested in that when we're doing pH and pOH calculations. So I know now that the hydroxide is 4 times 10 to the negative 4th molarity, so I'm right here. And then the shortest route would be to go this way and calculate pOH. You technically could go all the way around and it'll be 3 steps, it's fine, but I like to pick the shortest route. So to calculate pOH, it's like pH, but it's the negative log of the hydroxide. So when I do that, what do I get? I get a pOH of 3.4. So pOH, and then my pH, once I know that, it's easy. So this was 3.4. So I can easily go and subtract from 14 to get the pH. So pH is going to equal 10.6. Remember, no unit with pH or pOH. I think I have one more for you. Can you stand it? So here's another one. This one is ultimately we're trying to get here, and we're starting with a pH of 9.3. So this one you can go either way. It's going to be a 2-step problem. Let me see which way I went because I'm going to use my notes that I have. So I went this way. And then I used KW. Did I? Yeah. So anyways, if I I know the pH is 9.3, so I can calculate the hydrogen ion concentration first, even though they don't ask me for it, but I need it. So that would be 10 to the negative 9.3. So when I put that in, I will get 5.0 10 to the negative 10th molarity. So that's me right here with the hydrogen ion, but yet they don't want that. They want the hydroxide ion. So then I just have to remember that Kw, and I'm right here in the diagram, equals that hydrogen ion times hydroxide. So I can just sub in my 1 times 10 to the negative 14th and then put in my hydrogen and then solve for my X, which is OH. So when I do that, I get 2.0, I can't even read my writing, so hopefully I'm not wrong, 10 to the negative 5th. And remember molarity, because we're dealing, these guys are going to have the unit of molarity. So hopefully that helps, and then practice, because you will see these kind of calculations on your summative, which should be pretty easy, but you have to practice. So have a wonderful day.